Yeah.
Okay, so I make it 5 o'clock London time. We're in that sort of funny fortnight between America's time going forward and Europe's time going forward, which I have been caught out on before.
Yeah.
And I hope nobody's been caught out on this occasion. So welcome to the March. So welcome to the March SHAC seminar, which is also being relayed on YouTube and will be on our YouTube channel in due course. And if you're watching on Zoom, then you can ask questions directly in the chat box, and I'll call anybody forward who wants to ask a question or raise a point or whatever. If you're on YouTube, please put your query into the chat box on YouTube, and that will be passed to me. So this one seminar has been given by Professor John Power, who is Associate Professor of History at Virginia Commonwealth University in Richmond, Virginia. He studied the history of chemistry and related fields in the long 18th century, and his first book, Inventing Chemistry, was on Hermann Boer and the reform of the chemical arts. That was published in 2014. And it looked at how the Dutch professor reconfigured chemistry teaching at the University of Leiden to integrate it into the medical curriculum. As a result, the courses focused much on natural philosophy of chemistry as it did on practical and chemical operations. He's currently working, John is currently working on Joseph Priestley in America, which looks at Priestley's last 10 years of his life when he was an exile from Britain between 1794 and 1804. And he's looking at Priestley's effect on chemistry and natural philosophical community, and what this might tell us about the success of the chemical revolution going on into the 19th century. And that, I think, is going to, and then what we're about to hear, I think is probably part of that project, Defending the New Chemistry, the Columbian Chemical Society of Philadelphia, circa 1811 to 13. John, the floor is yours.
Thank you, Frank. And I'd like to thank the Society for the History of Chemistry and Alchemy, or Alchemy and Chemistry, for inviting me here today. And I hope you will find this this paper enlightening and entertaining. As Frank said, that this paper is part of a larger project on Joseph Priestley, specifically on Joseph Priestley's time in America, which took place during the last 10 years of his life, from 1794 till 1804. As most of you probably know, when Priestley emigrated to America, he, did his normal Priestley thing by becoming involved in political controversies, while at the same time finishing his monumental History of the Christian Church and a few other religious works. But notably, for our purposes here today, he revived his defense of phlogiston theory. What I am trying to do in my study overall is to look at Priestley's work in chemistry and natural philosophy during his last 10 years, but especially assess Priestley's impact that his presence and activities had on the American chemical and philosophical community through his publications, his participation in organizations like the American Philosophical Society, and also through his forging of personal relationships. This paper is on a topic that, chronologically anyway, comes sort of at the end of the Priestley in America project. I'm going to be focusing on a short-lived, largely medical student-led chemical society called the Columbian Chemical Society of Philadelphia. While this society and its one set of published memoirs did not have a dramatic effect on chemistry in the United States, I think that looking into this society's aims and projects and personalities will provide a glimpse into the chemical community, at least around Philadelphia in the 18 teens, and will show us a little bit about the Philadelphia community's concerns and debates. And like Frank mentioned at the close of his remarks, that this paper is part of a larger project, I think, on reevaluating the impact of the chemical revolution. That is, during the course of my research, I have uncovered several different individuals and pockets of individuals who expressed a growing skepticism uh, regarding some of the philosophical claims of Lavoisier and company's new or anti-phlogistic chemistry. And so that is, I guess, the kind of meta theme that I'll be talking about today. Let's see if I can change this slide. There we go. Okay. By the time that Joseph Priestley arrived in the United States in 1794, most chemists in the US were aware of the new anti-phlogistic chemistry. Um, Quite a few were keen to adopt it. And even if some were skeptical of some of its tenets, most notably its new nomenclature. But Priestley's presence in the United States, and particularly his participation in the uh, American Philosophical Society, ignited a great deal of discussion and debate on the French chemistry. Priestley published a series of pamphlets between 1796 and 1803. To be fair, they're the same pamphlet that he just kept enlarging and editing and republishing. Um, but these pamphlets reasserted, and streamlined his arguments in favor of his version of the phlogiston theory, or at least the version that he held in the 1790s. Um, Now, while uh, while he didn't, he failed to convert any American chemists to his phlogiston theory, or maybe reconvert them. His pamphlets did have an impact. One chemist who took Priestley's critique seriously was James Woodhouse, pictured there on the slide. Woodhouse was a Philadelphia native who earned his medical degree at the Medical College of Pennsylvania in Philadelphia, studying under the illustrious physician Benjamin Rush. Um, Woodhouse became the chair of chemistry at the Philadelphia Medical College in 1795 after Priestley, who was offered the chair, declined it. Woodhouse's reaction to Priestley's pamphlets was basically to get into the laboratory and test some of Priestley's claims. Now, while Woodhouse found no reason to adopt Priestley's phlogiston theory, he was also critical of the French chemists as well, corroborating some of Priestley's empirical claims regarding some of the more problematic assertions that anti-phlogistic chemistry made regarding the composition of various substances and also some reaction products. Famously, he corroborated Priestley's claim that the anti-phlogistic chemist had misinterpreted a species of inflammable air that was released during some experiments to reduce metallic calces to their original metals using charcoal as the reducing agent. Now, this debate ultimately led to William Cruikshank's identification of what he called gaseous oxide of carbon in 1801. And of course, this is the gas that we now call carbon monoxide. And I bring this up because I will come back to this episode later. Um, at any rate, as a result of these debates, Woodhouse became somewhat of a skeptic regarding the new chemistry. Now, he did not reject the new chemistry to the completeness and intensity that Priestley did. Nevertheless, he remained skeptical about many claims of the new chemistry, and felt that many of its tenets were tentative, meaning they had not been sufficiently proven, there wasn't enough experimental evidence, or even problematic. And as professor of chemistry at the Medical College of Pennsylvania, he conveyed this skepticism to his students. Now, in the early 19th century, the first decade or two of the 19th century, Priestley was joined by a few other English chemists, British chemists, I should say, notably Humphry Davy and Thomas Thomson, who, in pursuit of their own work, had also developed what we might, let's call a healthy skepticism of the new chemistry. For example, Thomson, who became a lecturer in chemistry at Edinburgh in 1802, published his textbook, System of Chemistry, in the same year, was very impactful on Woodhouse's teaching and later chemistry professors in the United States as well, when copies of that book made their way to the United States. Humphry Davy, of course, what his work was also very important during the first decade of the 19th century in the U.S. as well. His galvanic apparatus was all the rage in the United States by 1810. But more specifically, towards what I want to talk about today, his work at the Royal Institute, especially that showing that the common alkalis were compounds of metals and oxygen, and using his galvanic apparatus, and while doing this, discovering potassium and sodium. For our purposes here, the importance of this is that it shows that alkalis contained oxygen too, thus providing a counter argument to Lavoisier's claim that oxygen was the acid generator, was the principle of acidity. Similarly, Priestley failed with his galvanic apparatus to extract any oxygen from muriatic acid, a very common strong acid, and therefore, provided additional evidence that oxygen was not the acid generator. Woodhouse seemed to be a main conduit for the ideas of Thomson and Davy coming to the United States. Again, I mentioned his fondness for Thomson's book, but also it is likely that Woodhouse traveled to London and met with Davy perhaps around 1804. I'm still trying to nail down both the facticity and the time when Woodhouse visited Davy. But we do know that by 1805, 1806, Woodhouse's students at Philadelphia record in their notebooks experiments conducted in class where the students were inhaling nitrous oxide and then recording the results. Woodhouse's successor as professor of chemistry in Philadelphia was John Redman Coxe. Coxe came from a family of surgeons in Trenton, New Jersey, who traveled abroad, studied at Edinburgh and London before returning in the early 1790s to study medicine with Rush at the College of Pennsylvania. After his graduation, he took another trip to Europe and then eventually settled in Philadelphia in 1798. He was appointed professor of chemistry in 1809 after the unexpected passing of Woodhouse. Now, Coxe's only publication in chemistry was a small book called Observations on Combustion and Acidification, which he published himself in 1811. In many ways, this book continues the tradition of Priestley and Woodhouse by pointing out holes in anti-phlogistic chemistry. But Coxe's enthusiasm for this was spurred on by the recent work of Humphry Davy, to whom he dedicated his book. As Coxe stated in the preface, quote, "Davy has made gigantic strides and shown many opinions in chemistry to be erroneous," unquote. Among Coxe's critiques of anti-phlogistic chemistry were Lavoisier's theory of combustion, and here these were totally cribbed from Thomson's critiques, especially those in which it seemed like Thomson was able to show evidence or reactions where combustion took place, and oxygen didn't seem to be present. Another crib from Thomson in Coxe's work was the fact that anti-phlogistic chemistry could not adequately account for the action of gunpowder. And then going back to Davy's work, Coxe supplied evidence from Davy's work against the claim that oxygen was the acid generator. As a solution to these problems, Coxe suggested bringing back a version of the phlogiston theory. Again, citing as like the authority for this some remarks of Humphry Davy. Now, I note that this version of the phlogiston theory that Coxe recommended was not Priestley's phlogiston theory, but rather was similar, derived from Richard Kirwan's theory from the 1780s, in which hydrogen functioned as phlogiston. That is, hydrogen acted as the principle of inflammability and also acted as the true principle of acidity. So, chemistry at the Philadelphia Medical College, or the University of Pennsylvania Medical School, between 1800 and 1811 or 12, was full of critiques of the new chemistry. However, not all of Woodhouse's or Coxe's students agreed with this approach. In 1811, a group of medical students formed what they called the Columbian Chemical Society, as I hope to argue in many ways in opposition to the teachings of their professor, notably John Redman Coxe, who was the professor of chemistry at the founding of the society. Now, in addition to the possible philosophical disagreements that these students may have had with their professors, the students founded their new society in part because the previous local chemical society, the Chemical Society of Philadelphia, basically had gone defunct shortly after the death of Woodhouse. The society was founded by John Redman Coxe when he was a student, along with a few other students. But by about 1795, when Woodhouse became the professor of chemistry at the University of Pennsylvania, he became the president and basically ran the society until his death in 1809. Coxe, who then succeeded Woodhouse as professor of chemistry, would have been the logical person to succeed Woodhouse in running the Chemical Society as well. And in fact, in one of Coxe's letters that he wrote to the Board of Trustees to the University of Pennsylvania, he stated that his role in founding the Chemical Society of Philadelphia was something that was one of his qualifications for why he should be named professor of chemistry in 1809. For whatever reason, though, once he became the professor, he decided not to continue leading the society. And again, there was likely some animosity between Coxe and his students. And in the main, Coxe seemed less committed to teaching chemistry than his successor Woodhouse did, such that Coxe resigned his chair in 1818 as soon as a more proper medical a more proper medical chair became available to him in Philadelphia. At any rate, the new Columbian Chemical Society was organized by a couple of medical students, Thomas D. Mitchell and George F. Lehman, both of whom were medical students who studied or were studying in 1811 under Benjamin Rush, who still taught medical courses. He just didn't teach chemistry courses anymore. Both of these students were interested in the application of chemistry to medical problems, but I also point out that they also had an interest in chemistry for its own sake. Mitchell served as the society's first president, while Lehman served as one of the society's two vice presidents. In 1812, however, they recruited another young local chemist named James Cutbush to serve as the society's president, and Cutbush remained the president until 1814, until at which point the society disbanded. Cutbush's early training in chemistry is obscure, but it seems like he trained under an apprentice system in Philadelphia. He may have taken some chemical courses with Woodhouse, but at no point did he earn a medical degree, as did Mitchell and Lehman. They both earned degrees, and as did many of the members of the Chemical Society. In 1812, or I'm sorry, Cutbush made his living as an apothecary chemist. He had a shop in Philadelphia at one point, and he also made money by teaching public subscription courses in chemistry to anyone who was willing to pay in Philadelphia. In 1812, both he and Mitchell were appointed as professors to the new at the new Lutheran St. John's College in Philadelphia. Cutbush was the professor of natural philosophy, mineralogy, and chemistry, while Mitchell was the professor of vegetable and animal physiology. All right. Um, Beginning in October of 1811, the society began meeting. According to their constitution, they were to meet once a month. And the highlight of these meetings were to be papers presented by the members on, quote, new and original work in chemistry and the other sciences, followed by discussion of the group. Initially, the papers in the society were limited to 10 minutes so that the ideas contained therein could be fully discussed. And every member of the society had to present one paper in order to gain full admittance to the society. In October of 1811, some of the society's papers were published in a local newspaper called the Philadelphia Aurora, and this continued periodically through 1813. These papers provide a glimpse of topics that interested these young chemists. Included among the topics published in the Aurora were papers on chemical affinity, on light, two papers on oxygen gas, one on hydrogen gas, and one that was, quote, on objections to the anti-phlogistic theory of combustion. In 1813, as I mentioned earlier, the society managed to scrape together enough resources to publish a volume of their memoirs. These memoirs contain the constitution of the society as well as papers presented at the society's meetings. Now, interestingly enough, not all the papers that had been published that had been presented at the society were published in the memoirs. There was clearly a level of selection going on, such that the society's leaders, that is Mitchell, Cutbush, Lehman, and Franklin Bache, who served as the vice president of the society for 3 years, their contributions comprised 15 of the 26 papers published in the volume of the memoirs. The society disbanded in 1814, likely because several members, including Cutbush, Bache, and a handful of others, enlisted in the United States Army or in a local militia due to the War of 1812. I note that the society was not very large to begin with. I can only identify about 32 active members during the 3+ years of the society's existence. And I also note that the society's constitution said that a quorum for meetings was only 6 individuals. So it could be that, so we're not talking about a huge number of participants in the society. Okay, so there we go. So in the memoirs, in the little introduction to the memoirs, the anonymous author stated that the papers presented at the meetings could be divided into 2 general categories: the practical and the speculative. In the volume of the memoirs presented, there is a fairly good, I would say almost a 50-50 mix of practical papers versus speculative or theoretical papers. For the purpose of my talk today, I'm only going to talk about two papers that are in the speculative category, I suppose, because the two papers directly address both anti-phlogistic chemistry and also reflect the feelings of the chemical/medical students at the University of Pennsylvania in 1811 and 12. So the first paper I want to talk about, which is also the very first paper in the memoirs, was presented by Thomas Mitchell, who's pictured there on the slide. Obviously, this is Mitchell older, looking older than when he was a student at the Pennsylvania Medical School. Anyway, his paper is called Remarks on the Phlogistic and Anti-Phlogistic System of Chemistry. Now, this essay contained a defense of Lavoisier's anti-phlogistic chemistry, likely in response to Coxe's book that he on acidification and combustion that had just come out a few months before Mitchell presented this paper to the Columbian Chemical Society. Now, in this paper, he never mentions Coxe directly, but a year later, Mitchell presented a direct critique of Coxe's book. But here, what he does is he takes a strategy of addressing an event that occurred 10 to 12 years earlier. Specifically, he recounted Priestley's and Woodhouse's claim that the anti-phlogistic chemist had misidentified or misunderstood the species of inflammable air produced when reducing iron in charcoal. Now, this is the episode that I mentioned earlier in the talk. Now, the issue here, again, was that the inflammable air that was generated during this reduction was inflammable. That is, it could be combusted further, but its other physical characteristics did not, it wasn't the same gas as hydrogen. Priestley, of course, interpreted this anomalous inflammable air as, in terms of his phlogiston theory, and according to Mitchell, Woodhouse saw this anomalous air as a hole in the anti-phlogistic system. As I mentioned earlier, eventually the British chemist William Cruikshank identified this air as a new air related to fixed, or what was called at the time carbonic acid air, but was just not fully oxidized. So Cruikshank called it gaseous oxide of carbon. We call it as carbon monoxide. Mitchell portrayed this episode as a triumph for anti-phlogistic chemistry, since this new air was eventually accommodated by Lavoisier's theory of oxidation and combustion. It was simply fixed air in a lesser state of oxidation. Mitchell took this as a lesson for why one should not doubt the tenets of anti-phlogistic chemistry. As he recounted, Priestley entered into this debate with his biased view, rejecting Lavoisier and promoting his own phlogiston theory. And Woodhouse should not have succumbed to his doubts. And as a result of this, Mitchell argued, they were led astray and led into believing false theories. But worse than this, in falling into this error, they, quote, also led thousands of others astray. Thus, Mitchell concluded that the lesson here was to avoid false theories, but rather stay committed to the received view, which is Lavoisier's anti-phlogistic chemistry. As he summarized, quote, if Priestley, Woodhouse, and others among the most celebrated chemists who ever lived were deceived merely by mistake, and from that deception were led to adopt false theories, we need not wonder that others less famous in the scientific world should be deluded in a similar manner. Now, what's interesting is after he makes this claim, he then makes another generalization which is that this then tells us that we need to reject the idea that there exists a principle of inflammability. But on further thought, which is quite interesting, is that he states that by analogy, we should reject the principle of acidity too. Now, this is very interesting because it's ambiguous whether Mitchell is talking about John Redman Coxe, who, of course, uh, proposed reviving phlogiston, hydrogen as phlogiston, right, as both the principle of inflammability and the principle of acidity. But you can also read Mitchell's paper as a rejection of Lavoisier's theory of acidity too. Recall again that Lavoisier held that oxygen was the principle of acidity. Um, in any case, Mitchell says that both alike are improper, and he gives an example of neutral salts, arguing that when you have an acidic, an acid, and an alkali, and argue that acids have a principle of acidity to make them acidic, and alkalis then maybe have a principle of alkalinity to make them alkaline, and when they combine together, they create a neutral salt. So does that mean the neutral salt has a principle of neutrality? And he kind of poses this argument as a means of showing the absurdity of thinking in this way. So he concludes that neither acidity nor inflammability could be attributed to one ancient or principle, but rather that the effects of that the property of inflammability or acidity are the results from what he calls relative causes and not attributable to a single principle or agent. So after I read this paper, I thought, wow, that's some advanced thinking there. And then the very next paper in line in the volume is by Franklin Bache with the title, An Inquiry into What Circumstances Will Warrant Us to Justly to Reckon Any Substance a Principle or Common Property of Any Set of Bodies. Now, what's interesting about this is that Bache, in effect, argues that, well, there isn't a principle of inflammability, but there certainly is a principle of acidity, and it's oxygen. And how he goes through this is as follows. First off, he defines what a principle is. And he says what it means to be a principle in chemistry is that a substance, any substance that uh, exerts a particular effect needs to have the principle. And the presence of that particular principle needs to cause that effect in any substance. Now, to get at this, he proposes a comparison between hydrogen as the principle of acidity versus oxygen as the principle of acidity. Now, again, I just to make sure we're all on the same page here, that this is again a way of comparing Lavoisier's principle of acidity versus the principle of acidity that was just argued by John Redman Coxe in his book. What Mitchell argues here is that uh, is that he begins with oxygen, and he argues that we can assume that oxygen is present in all acids because most acids contain oxygen, and that the most notable acid where this is not the case is, of course, muriatic acid. But he says muriatic acid has not been sufficiently analyzed. And so we can conclude then it is probable that oxygen is the principle of acidity. On the other hand, however, there are many substances which contain hydrogen, for example, the hydrocarbons, which are not acids. So therefore, we cannot say with any kind of certainty that hydrogen should be the principle of acidity, right? Now, what he does then is reasoning by analogy. He says since the decomposition of a substance with an acid is analogous to the decomposition of a substance through combustion, therefore he reasons by analogy that since there can be no principle of that hydrogen cannot be the principle of acidity, that therefore it cannot be the principle of inflammability either. And again, this is all a critique of John Redman Coxe's argument from his book, published just a few months before Bache reads this paper, um, uh, but without mentioning Coxe's name or even mentioning phlogiston. Okay. Now, let me see. Let me look at my time here. 35. Yeah. So let me just say very briefly that these two papers are, clearly engaged with critiquing a position taken by one of their professors that the students didn't like. Just for fairness, I also want to point out that not every paper in the volume does this, and that many of the papers are of a practical nature, such as conducting analyses of mineral waters or mineral ores, or ways to manufacture or generate in the laboratory various chemical reagents. And actually, James Cutbush publishes a paper that includes a novel, a test for arsenic involving an iron acetate, involving iron acetate as the reagent. And I should also point out that there are other speculative papers too. And what's interesting here is that there's at least two, maybe three or four other papers, depending on how you want to read them, that talk about the effect of plants generating oxygen when exposed to light. And what's interesting about most of these papers is that Priestley tends to be the main source that the students use when discussing the issue of how, well, what we would call photosynthesis works. So I'll put that out for you, and we can maybe talk about it during the Q&A if people are interested. All right. So conclude. Again, this is still a project that is it's in its infancy. But what I'd like people to come away with is that just to make the point that even by the second decade of the 19th century, anti-phlogistic chemistry, its validity, the reliability of its claims is still a source of debate. Certainly in Philadelphia, probably other places in the United States, in Britain, other places in the world too. The second is that in Philadelphia, there is very much a skeptical slant among the chemists towards the new chemistry. The chemical professors, Woodhouse and John Redman Coxe, are very skeptical of many of the claims, and that they are, if not in direct contact, certainly through the exchange of publications across the Atlantic Ocean, are very much interested in skeptical claims being made by people like Thomas Thomson and Humphry Davy. And the last thing I'd like to point out, especially with the Columbian Chemical Society, is that there is very much a tension here between the older generation of chemists and the newer generations of chemists, where they disagree in their opinions, and that the younger chemists tend to be more on board and more willing to defend Lavoisier's new chemistry, again, 20 years past, when it was finally, hammered out by Lavoisier and company, compared to the older generation. Okay, that's it. Thank you, everyone, for listening.
Thank you, John. That was really, really interesting. I mean, there are a lot of these small societies around in Britain, and I hadn't quite realised they were um, around so much in the United States as well. Um, so perhaps I can exercise my usual chair's prerogative and ask the first question, and that's about the politics of all of this.
Yeah,
Um, in Davy's case, he becomes very anti-French. I mean, as politically, he really doesn't like. I mean, he did have a sort of brief fling of Jacobinism
yeah,
in his late teens, and I think he's probably trying to get over that. But he takes a very sort of dim view of French chemistry and of France generally. Now, that's not the same as Priestley, because Priestley was a great supporter of the revolution, but doesn't like Lavoisier chemistry at all. So there doesn't seem to be any straightforward mapping of people's views on chemistry um, onto their political views. And I'm just wondering about the people you've been talking about, Woodhouse, Mitchell, etc., back. Um, were they pro-French? Bearing in mind the French gave a huge amount of support
yeah,
in the 1770s, early 1780s to gaining American independence. Um, and as you mentioned briefly, the War of 1812 was where we burnt the White House down.
yeah,
Uh, was quite a major incident
yeah.
that isn't really played up too much by British historians. I assume American historians take a well different view of that. So, could you say something about sort of the politics of this sort of
Yeah.
chemistry?
So, well, I know for sure. So Priestley, of course, was very pro-French, right? Even though he disagreed with, there's a great, so one of the first rebuttals of Priestley's first, considerations of observations and considerations on phlogiston and the decomposition of water pamphlet, 1796, was a rebuttal by Pierre Adet, who was Adet was a uh, worked with Lavoisier in Lavoisier's lab, was described by Carleton Perrin as earlier before this as one of Lavoisier's on Lavoisier's hatchet squad, right? And then in the mid 1790s was an ambassador from whatever from the French Republic to the United States, and so he was in Philadelphia. And the thing is, you know, he and Priestley personally, as far as I can say, as far as I can tell, got along great. And actually, Priestley had asked Ade at one point if he could get Priestley out of the United States and into France. Nothing came of that. But personally, they got along, even though they disagreed about chemistry, right? And Priestley was very much the type of person who disagreeing with something, with one of his claims, wasn't going to end your relationship with him, provided that you had a polite or gentlemanly like discourse was and debate was something that Priestley really enjoyed doing, right? Um, I know that um, uh, again, like I said, I think Woodhouse traveled to London. I think I read somewhere that John Redman Coxe may have also traveled to Britain at some point. I haven't had time enough to track that down for sure. So there were good relations with some of the American chemists with Britain all the way up until the War of 1812, because both of these papers that I talked about today were read in 1811 before the war came out. I don't know if there were tensions leading up to the war at that point. Um, uh, but uh, but I do know, again, and I don't necessarily know the political convictions of many of the students or even John Redman Coxe himself. Although I do know that several of, like Bache, for example, uh, and Cutbush joined the army, and both of them at one point or another ended up teaching chemistry at West Point, which is the military, the U.S. Army Academy uh, in the United States. Um, but apart from that, I'm not really sure. Um, there, yeah, I just leave it at that. I'm not really sure. I do know that in the first decade of the 19th century, there was correspondence and possible trips between the United States and Britain, but at that point, I don't believe that relations had between the United States and Britain had soured all that much.
I,
Um,
I, I spent a sort of 2 or 3 days in Yale reading from Benjamin Silliman's
oh, right.
diary, and Silliman spent probably about a year in total in Britain, in the Netherlands, uh, and in Scotland, but England and Scotland.
Yeah,
And it does strike me that sort of a lot of American scientific figures do at some point spend
yeah,
extended periods of time. But I mean, Joseph
yeah.
Henry is another good example, but it's
Okay.
sort of the next generation.
Now, when
generation.
was Silliman's trip?
So
When was Silliman's trip?
I think it's 1805, 1806, something
Okay, so
like that.
yeah,
So,
possibly this similar time frame to when Woodhouse supposedly went.
yeah,
So yeah.
yeah. Right. If anyone's got any questions on Zoom, put your hand up or type it into the box. And if anybody's got um, questions on YouTube, type it into the box and it'll be um, passed to me. Otherwise, I shall keep on talking to John. And Priestley seems to have. Oh no, no, somebody's come up. Yep, Larry Stewart, who asks from YouTube, can you say anything more about the use of galvanic apparatus amid the Pennsylvania disputes?
Hmm. Uh, so the short answer is no. Mainly because I haven't just haven't gotten into it uh, that much. Uh, I do know that Priestley had an apparatus shipped over when he heard about it around 1800, and he did some work on it, and he published at least one paper in an American journal, and may have actually published a paper in Nicholson's journal in Britain as well. And for Priestley, of course, electricity is just phlogiston, right? And I suspect that he also that Woodhouse may have been present and may have acquired his own apparatus. Um, but I have not delved into that deeply enough at this point to know what, if anything came of it. Um, so unfortunately, I don't know. I do know this though, that one of the issues about keeping up with what you might call the cutting edge of chemistry in the United States is the lack of good equipment. I mean, most of it has to be imported from Europe. For example, there are letters from Priestley to uh, 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 now I'm blanking on his name, to folks that in Britain, asking them to basically get pneumatic apparatus both for himself and for his friend Thomas Cooper. I also suspect that Priestley um, was able to help Woodhouse acquire pneumatic apparatus as well. And I also have circumstantial evidence to suggest that, in fact, that in many ways Priestley brought pneumatic chemistry to the United States because, again, you couldn't get apparatus, and um, Priestley remarks in a couple of his papers about how, you know, uh, uh, about how Dr. Priestley showed him experiments that he made in his own laboratory and so forth. So you kind of almost got this sense that Priestley sort of mentored Woodhouse in pneumatic chemistry and how to work the apparatus and helped him equip his own laboratory. Um, and I suspect that a similar thing may have happened when Priestley heard about uh, the galvanic apparatus. Um, uh, before Davy started to do it, and it was William Nicholson, and is I think Priestley's source of information on it. But
I
um,
mean, it is quite easy to make a sort of small galvanic apparatus.
yeah,
The problem is when you scale it up and using Cruikshank's
yeah,
troughs, it starts being very, very expensive very, very quickly. So people like Wedgwood
yeah,
and Newman, I mean, really specialist companies are
yeah,
bought
yeah.
into that. Now, can I ask just about some Priestley's direct influence? I mean, I've been to Philadelphia more than any other city in the United States. And I still have not been to Northumberland. Every time I go, I think I'm going to Northumberland, and it's just so far away. It's at least half a day's drive, I would think. So it must have been a sort of 3 or 4 day
It was
journey.
5 days by carriage,
5
according.
days, yeah. So I mean, how did Priestley go and visit for a month or so and come back, or things like
So,
that?
so he would make several trips a year, three or four maybe, and I'm not quite sure how long each trip would be, but it would, he would be in town for a while because again, it takes five, as he said, uncomfortable days in a carriage to get there. And then when he was there, he would usually, present stuff at the American Philosophical Society. He would also give sermons because as a clergyman, he would, kind of give guest sermons at various, uh, you know, uh, non-conforming churches. Of course, in the U.S., there's no conforming or not conforming, but churches that had the sort of the Unitarian slant to them,
Yeah,
just where Priestley was. Um, uh, yeah, but he was there, and he had I want to say one of his sons had a residence there, or he knew people there that he would stay with, and so it would be for, I imagine, at least a couple of weeks before he would make the trip back. But and then again, as he got older, that trip became even more difficult. Um, so
yeah.
yeah.
And one does vaguely wonder why he chose Northumberland as his.
Well, I mean, it's so his the goal there is his sons preceded him there, and there was a whole group of the sort of nonconformists who bought land in the middle of nowhere, and the goal was to create a dissenting community so that religious dissenters from Britain, right, would be encouraged to come to Pennsylvania and form this sort of semi I don't want to say autonomous, but semi-autonomous community. And Priestley was going to found a church and a school and the whole bit. But
I
never
mean,
really off the
I mean,
ground.
after all, people like Coleridge and Southey
Yeah,
intended to sort of go to the banks of the Susquehanna, and
yeah,
deliberately, I think, to be in proximity to Priestley and set up this Panasocratic
yeah,
community. But like so many romantic projects at the time, it sort of collapsed. They didn't even get as far as a shipped thing.
yeah,
Yeah,
yeah.
yeah,
Priestley petitioned, I think, the government of Pennsylvania for money to help him found his academy, and it was never, even when he was friends with Jefferson and Jefferson was elected president, right, he couldn't get it off the ground.
yeah. So, and I think that's to do with sort of tyranny of distance and time, tyranny of time, just to sort of
Yeah.
travel. Yeah. Okay. Any final points, questions? Students being well known not to agree with their professors, which is a strong tradition after all. Okay, well, in that case, I'll draw this to an end. So, thank you so much, John, for that really, really interesting talk. Is there a question going up there from Samsung SM? You're muted if you are asking a question. Ah, right, yeah. You're muted. You are muted. Robert Ewan, can you demute him remotely?
I can't demute him. I asked I asked him to unmute, but I think he didn't see that. Hello, can you unmute your microphone?
I sent him a chat.
Okay, thank you, Rob.
I don't think any response.
He's still
got a lot to say.
He's still talking. Okay, I think I'll give up. No.
Give it up.
Okay, right. So just to remind everybody that the next seminar in this series is at the moment scheduled for 21st of May, but that might change. We're still negotiating with the speaker. There are various other things in play there. On the 10th of April, which is not too far away, we've got the meeting at the Maison Française in Oxford, commemorating the life and work of Bill Brock. If you want to attend, send me an email and I'll add you to the list of attendees. There's no registration charge for that meeting. And for this particular seminar, I'd like to thank Rob Johnson and Yuan Tao for managing all the technical stuff that I can't manage. But last of all, thank you, John, for giving us such a really, really interesting insight into early 19th century Philadelphian chemistry. And bearing in mind where Philadelphia now is in chemistry, it's beginnings, really, I suppose.
Yeah, in the United States.
Yeah. Well, yes. Yeah. Okay. Well, have a good day, evening, night, depending on where you are in the world, and see you at the next seminar, which I say hopefully will be on 21st, but that might change. Okay.
Thanks, Franks. Thank you, everyone.
You're
Thank you.
welcome.
Thank you very much.
Thank you. Bye bye.